Hello, hope all of you are doing good. Now, from this video onwards, we will try to understand the concept behind the Splunk multi-site clustering, and as well as we will of course see some demo as well. But we will start with the understanding of basic architecture of it. Then slowly we will move to the demo part over there. Okay, so what is Splunk multi-site clustering and why we basically use it? Now, before we come to the why part, let us try to understand first what is a Splunk multi-site clustering. Now, this video will be part of the Splunk admin playlist, the Splunk 0 playlist, if you see it over here. Now, previously we talked about the basic indexer clustering as well, and how to connect to the search cluster with the indexer clustering as well. Now that's why I am just starting with the multi-site clustering and all of its related videos over here. Okay. Now, what is Splunk multi-site clustering? Now think about this one. So we previously talked about indexer clustering, right? So over there we basically connected lot of indexer peers, basically the peer nodes, to make it a cluster over there, right? Then we connected with the either single searched or searched cluster over there to search those particular data. And while doing that, we also talked about two important stuff called the replication factor and the search factor as well, right? The replication factor basically tells us like how many copies of the data we will be storing in the cluster, and search factor is basically telling us like how many of those data which are basically storing, which how many of those copies basically which we are storing in the cluster will be searchable. Correct. So in multi-site cluster, so the similar concept exists, but we are basically dividing this whole setup into physical sites. So let's say I have two sites like this one. So site we can thought of as a physical site. Let's say a site could be residing in London. So we can basically create indexers or search peers which are tagged to site 1 London over here. Okay, and we can have another site. Let's say I'm just giving an example of two sites over here. Let's say it's based on Mumbai. So whatever peers I will be creating over here, so it will be basically tagged to this particular sites. So if you see, like when we talk about sites, we are basically logically creating a boundary of those peers over here. Correct. So basically, like if I just talk about in a very simplistic way, so we have our indexer cluster, right? So if we just replicate, if we just create another indexer cluster and assign this to cluster a separate site names, almost that will become multi-site. But there are a lot of differences while we will be doing the configuration, but at least logically we can visualize it in that way. Okay, but there are a lot of advantages while creating these sites, which we will see it later as well. Okay, so each and every site will have their corresponding peers. Let's say there are n number of peers or indexers over here. So whenever we generally talk about multi-site clustering, we talk about the indexer clustering only over here. Okay, so this peer, so site 1 has their own set of peers, site 2 will have their own set of peers as well, and there will be forwarders which will be sending the data to this peers over here. Correct. There is no change in that part. So indexers will be receiving data from their corresponding forwarders, or heavy forwarder could be. Okay. Now one important thing we talked about when we configured the indexer cluster is there will be a master node. So in multi-site cluster also there is a master node. Now this is important because, as I said just now, if you see, like we are basically grouping this search peers by sites, right? That means this indexers, while we'll be seeing when we'll be seeing the demo, we have to give a site name while we'll configure the multi-site clustering for each and every peers over here, right? So that means they are site aware, like they know which sites they belongs to. Similarly, for site 2 indexer also, they know they belongs to the site 2. But what about a master node? Because this guy will be responsible for managing the whole operation stuff over here, correct? So when we will be doing the configuration, the master node we have to assign to a particular site. It could be site 1, it could be site 2, or it could be any number of sites. I think Splunk supports, I think, total 64 sites. Okay, so so it could be anything, but we have to assign a site to the master node. That is important over here, and we will see that in future where we will be, when you will be doing the configuration. So there is a specific need for it to have the site name over here, but at least for now we will just go with that approach. Master node has to belong to a particular site. Now, as the scenario with any other cluster in Splunk, there should be a searched or searched cluster, correct, for both of these sites. So here also for the multi-site, for each and every site will have their own searched and the searched cluster as well, like, or the searched cluster as well over here. You can connect a searched cluster over here as well. Okay, now this is the, if you see the architecture wise, it is very simple. We are just dividing this whole cluster concept into into site wise basically, but configuration wise it is way different compared to the normal cluster configuration, which we'll be discussing shortly. Now let's talk about the communication, why we are creating these two sites when there is not something special is happening. So let's see that. So whenever the search peers are communicating with each other, that means they are basically replicating their data to this search pair, so that whenever we'll be searching the data, the data is always available to the search head over here, right? So these peers always talk to each other or replicate their data. Even for site 2 also, these pairs always talk to each other and replicate their data. In addition to that, it replicates across the site as well. So this is an important stuff. Okay, so that means it is not only replicating their data to their corresponding sites, it's also replicate across the sites as well, so that we can maintain our data throughout the site, that's why it is called the multi-site cluster. So one advantage is like the disaster recovery, right? So when one site is down, your searches will still run with the site 2 because of this replication over here. Okay, now in terms of other communication, search head will always be communicating with the peers over here. And if you see, this search head are also site aware, like they knows which peer to access over here. So generally you can configure the multi-site cluster in such a way that this search head will always try to access the local peers only, until and unless it is necessary. Like it can be configured in fully that way, like it will always access the local peers only. Okay, so that is called something called search affinity, which we'll talk later. So similar stuff, these searchers will also talk to these peers internally. So basically they will send the search and this will basically send it the data over here, right? This is normal communication. Even this search head will have communication with the master node as well, because the master node will be the one who will be managing all this stuff over here. Apart from that, this indexers also will be communicating with the master node as well. Okay, so this is the overall picture about a multi-site cluster. So I just shown two sites over here. You can extend to up to 4, 5 or up to 64 over here. Okay, and these are the different level of communication it can have. Now one important question arrives is, when we configured our indexer cluster, we talked about the replication factor, search factor, those stuff. So what will happen over here in case of multi-site cluster? So let's talk about the replication factor over here. Now for Splunk multi-site clustering, so there is a concept. So there is basically there is no replication factor, although that configuration is saved somewhere. We will see that when we will be doing the demo. But the main concept for the multi-site cluster is the site replication factor. So this is the change from the normal clustering configuration. So it has a site replication factor. This is important. Let us first see like where we can define the site replication factor. We need to define in the manager node over here. And in terms of its controllability, so we can control the number of copies. So basically the replication factor tells us how many copies of that buckets or data we will be storing in the cluster, right? Apart from the actual data, how many copies we will be storing it over there, right? So we can control the number of copies across the entire cluster as well as across each site as well. at the site level as well. So this is important stuff which is not present in the normal clustering replication factor. So that's why they have a separate name called site replication factor. Even there is, you can control the replication policy in such a way that the indexer or the search peer, which is basically generating or originating the data, basically let's say from forwarder the indexer 1 is receiving the data, right? So that will become the data originator, right? So based on which peer is originating the data, you can control how many copy that particular peer will get or not. That is also possible over here. So in terms of syntax, it looks something like this one. So in the servers.conf, it will be something like this one, site replication factor. Now if you see, this is the syntax over here. Over here, if you see, there are three things. One is called the origin, another is called the total, and another is the site names, if you see. Now among these three, this origin and this total is mandatory. Rest of the stuffs are optional. Now what do you mean by origin? So origin means the peer which is basically originates the data. So I can mention, like, if the data is originating from peer 1, it needs to maintain 2 copies of the bucket. So basically this n tells me the minimum number of copies I can have, minimum number of copies of the data or the bucket, because in Splunk data are stored in terms of buckets, right? So how many copies of the buckets that will be held for a particular site. So origin is basically telling me the search peer which is originating that particular data, where the data is getting originated, it will get n number of copies over here, and that is mandatory. And apart from that, so if you see, like, we are not explicitly telling it over here, like which site needs to get what many number of copies over here. If you want to maintain the explicit definition, you need to go to something like this one, the site one, which will be basically when you will be configuring the search peer. For each and every peer, you need to give the site name, right? So that exact site name, you need to use it over here and then tell how many copies it needs to get. Similarly, for all the sites you can get, even like you can omit the site as well. Like even if you want, you won't tell explicitly like what will be the number of buckets in that, but that needs to go to that particular site. In that case, the total, what we are telling it over here, total means like across the cluster, like across the multi-site cluster, across the sites, how many total number of copies we want to maintain over here, the minimum number of copies. So that total will govern the number of copies we will store in those sites which we are not explicitly stating it over here. Okay, we'll see a lot of examples over here now. So let's see the first stuff. Now if you see in this particular example, we are talking about 4 site cluster over here. That means there are 4 sites over here. Now in the site replication factor configuration, we have given the value 2 for the origin. For site 1, we have given 1, site 2 we have given 2, site 3 we have given 3, site 4 we have not explicitly maintained any value over here in the configuration, and the total is 8. That means there should be, across all sites, there should be 8 copies of the data over here needs to be maintained over here, right? The minimum number of data at least needs to be maintained over there, correct? So based on this configuration, let's see in this particular table, like what will be the number of copies each and every sites will be getting. Now let's say we'll start with the site 1, because let's say if the site 1, the data is getting originated from the site 1, that means let's say we have a forwarder which is sending the data which is connected to the site 1, any of these peers over here, which basically belongs to the site 1. So when we talk about site 1, that means the peers belongs to the site 1. Okay, that we need to keep in mind over here. So if my site 1 is if my data originates at the site 1, so how many copies site 1 will get? Now if you see, it depends on these 2 configuration, because I have defined explicitly 1 for the site 1, that means site 1 should get 1 copy of the data. But I also maintain like the origin, that means I said if the data originates from that particular site, it should get 2 copies of the data. So internally what Splunk will do, if there is a conflict, it will take always the greater values over here. That means my site 1 will get 2 copies of the data over here. So that's the rule over here. Now what would be the number of copies at the site 2 in this particular scenario? So site 2 we have explicitly maintained 2, that means site 2 will get 2 copies. Site 3 will get 3 copies over here. I have explicitly maintained this one over here, and the total is 8. So how many are left? So 1 is left, so site 4 will get the 1 over here. If you see, for the site 4, the total is governing how many copies of the data it will get over here. So basically Splunk will try to distribute it as evenly as possible over here if we have multiple sites which we have not explicitly set over here. Okay, now let's continue. Let's try to see what will happen when the site 2 is the originator over here. So site 2 we have explicitly said like the copy should be 2, even for origin also 2, that means site 2 will get 2. Now site 1 will get 1 over here because it is not the originating site now, right? That's why it is, according to this rule, it will get 1. Similarly for site 3 will get 3, total is 8, then site 4 will get 2 over here. Okay, now when site 3 is becoming the originator, so as site 3 we have said 3 over here, origin is 2. As I said, there is a rule which will give, when there is a conflict, it will take basically the greater one. So that's why my site 3 will get the 3 copies of the data over here. And similarly for site 1 will get 1, site 2 will get 2 according to this particular config over here, and as total is 8, so site 4 will again get 2 copies over here when the data originating from the site 3. Now if the site 4 is the originating site, so let's see what is happening. For origin we said needs to maintain 2 copies, that means site 4 will directly get 2 copies of the data over here. Now site 1 will get 1 according to this configs, site 2 will 2, and site 3 will be 3. So that will become 8 over here. Now this is interesting because we have defined total in such a way that even though I have not explicitly said like site 4 needs to get this much, but if you see, like when site 4 is becoming the originator, Splunk has to assign these 2 copies over there, right? So accordingly other sites I have set it up over here. So I need to set my total in such a way that it also take into consideration this particular scenario as well. So that's why there are certain rules exist which will basically governs how we need to consider this total value. So let's talk about them. So first rule is, so let's say if there are some non-explicit sites, then the total value must be at least the sum of all explicit site and the origin values. So this is very clear. So let's take an example. So let's say we have a 3-site cluster and I have given the site replication factor as something like this one. I have given origin, I have given site 1, I have given site 2, but I have not given third site, site 3 over here. So what will be my total? So in this case, as per this particular rule, it has to be minimum 2 plus 1 plus origin, like explicit values plus the origin values over here. That means 5 over here. Let's take another example. So let's say we have again 3-site cluster with this particular settings. Origin is 2, site 1 is 1, site 3 is 3 over here. So what will be my total? I need to set up over there 3 plus 1 plus 2, that means 6. At least minimum 6 I have to give at the total. It could be greater than that one as well. Now let's talk about the second rule. So let's say if all sites are explicit, that means you are explicitly mentioning all the site and their corresponding number of copies over there, then the total must be at least the minimum value necessary to fulfill the dictates of the sites, okay, and the origin values. So let's take an example. Maybe this sentence is hairy, we will forget about this one, we will take this particular example. So let's say we have a 3-site cluster over here. We have given something like this one, okay. Now we are saying the total has to be 3, at least 3. Why? If you see, according to this rule, we have given, as this is a 3-site cluster, and I have also explicitly maintained site 1, site 2 and site 3 over here and their corresponding value, as well as origin value, because origin is mandatory, right? I have to give that one. So that means according to origin, what I am saying it over here is each and every site, whenever it is becoming the origin site, it should get 1 copy. Even when I mentioned it explicitly, I also mentioned it as 1 copy only. So that means I can just add these 3 together to make the total over here 3, right? Now let's take another example over here, which is little bit complex. So let's say I have the same 3-site cluster with this particular replication factor over here. Origin is 2, site 1 is 1, site 2 is 1 and site 3 is 1. Then in this case, what will become my total value? Now let us think about this one. So let's say when site 1 become origin, it has to get 2 copies, right, instead of 1 copy, because there is another rule. When there is a conflict between origin and site, it has to get the greater values over here. So that means 2 for the site 1, then site 2 and site 3 will get 1 copy when site 1 is the originator over here. So at least 4 we need. That is what it is saying it over here, the minimum value necessary to fulfill the dictates of the site and the origin value over here. Okay, so that's my total value. So just take another example over here. Let's say about this one, right? So where origin is 3, site 1 is 1, site 2 is 2 and site 3 is 3 we have given. So what will become my total value? If you see, when site 1 become origin, basically the generator site, so it has to get 3 copies, right? So at least we need 3 plus 2 plus 3, 8 copies over here, right? So to shortcut this one, what we can think of it like the site which has the least number of values, right? If we can just replace this one with the origin values and then add up other stuffs, at least we'll get the total value over here. Now let's talk about the third one. So third one is basically very simple one. So when the total value can be greater, basically the total value can be greater than the total set of explicitly we have set the values, right? Now in that case, those remainder copies of the copies are distributed across all sites. That is what I was talking about before as well, with preference given to sites with less or no copies, so that the distribution is even as possible. So this particular rule is actually like how Splunk will be distributing the remaining copies over here. Let's take an example. Let's say we have a 4-site cluster with this particular settings over here. Okay, we have specify origin as 1, site 1 as 1, site 4 as 2. We have not given any details explicitly about site 2 and site 3. And the total I said is 4. So what will be happening over here? So let's say if my site 1 is becoming the originator site or origin, that means site 1 will get 1, because both of the places I have given 1 over here. That makes sense, right? So 1 is gone. Site 4 has to get 2 because I have explicitly said that. So 3 copies are gone. That means I have only single copy over here, right? There will be 1 remainder copy over here, and that will get distributed randomly between 2 and 3 because there is only single copy and I have 2 sites to look into it, right? So that means Splunk will automatically randomly pick up 1 site and it will basically place that particular copy over here. Now we are talking about sites. Just be careful that when Splunk internally will be doing it, it will be placing that copy in a peer, search peer, right? Site is a conceptual, like it's a logical concept. Peer is the actual concept, physical concept, right? So let's move on. Now let's say if my site 2 is becoming the origin, then what will happen in this particular scenario? So site 2 will get 1. According to this configuration, site 1 will also get 1 and site 4 will get 2. That means site 2, site 1 and site 4 will consume all these total 4 values. In that case, there will be no remainder copies, right, to distribute to any of the site 3. So this will also be a valid scenario. Now, as I said, most important things are peer should be ready to get that copy. So if there is no peers available or peers are down, there will be a lot of scenarios will be available. Let's see through that one as well. Okay, so let's take an example of peer level stuff. So let's say I have a 3-site cluster with this particular settings only. I have not explicitly said any site level how many copies should be stored. So I have just given origin equals to 1. That means the site which is generating the data should get at least 1 copy, and there should be a total 9 copies over here. Now site 1, we have 3 sites, right? Site 1 has only 1 peer, site 2 and site 3 have 10 peers each. Now what will happen? First of all, Splunk will guarantee that, because we have not explicitly said any site names over here, so it will first guarantee that at least 1 copy will go to each and every site. That means 3 are gone among this 9 copies, correct? So that means 6 are left. Now when 6 are left, how it will be distributed? As I said, Splunk will try to distribute as evenly as possible. So we have 3 sites, right? Site 1, site 2 and site 3. So ideally Splunk will try to distribute among them together, right? Like site 1 2 copy, site 2 2 copy and site 3 2 copy. But the problem is site 1 has only 1 pair which already got 1 copy by Splunk because of this guarantee, right? So it does not have any other peer left to get the another copy over here. So what will Splunk will do? Splunk will not touch the site 1 because that peer it has already got 1 copy. Now it will distribute evenly between the site 2 and site 3 over here. So this is also a valid scenario over here. Okay, we need to keep in mind how Splunk will keep those copies. Now, as I said, like everything is depends on peer, right? What if my peers are down? Let's take an example over here as well. So let's say we have a 4-site cluster with this particular settings over here. So we have mentioned origin 1, site 1 1, site 4 2 and total is 5, correct? So similar example, if my site 1 is becoming origin, so what will happen? Site 1 will get 1, site 4 will get 2, 3 are gone, 2 are left. The remaining 2 will be distributed between site 2 and site 3. That is fair enough, right? As I said, Splunk will evenly try to distribute that one. Now let's say when Splunk is trying to distribute between site 2 and site 3, all the peers of the site 2 are down. Site 2 is not able to receive any of the copy over here. So what will Splunk will do in this case? The remainder copy, like which is supposed to go to site 3, it will go to site 3 because site 3 is up, and the other copy which is supposed to go to site 2, it will be on hold, okay, in reserve until the site 2 is joining the cluster. So if you see, this is the scenario where we will face that situation where the search replication factor is not met over here. Okay, so this is an interesting scenario over here. So whatever we talked about the replication factor over here, and that basically tells us, like, because in the replication factor what we are basically telling Splunk to maintain the copy of the data or the buckets throughout your cluster as well as throughout your sites as well, right? So that means the initial benefit we can get is like we can get extra layer of data partitioning, right? So as I said, like those indexers or search pair can be logically partitioned based on sites as well, right? Or group based on sites as well, right? Now second thing is the data disaster recovery, right? It's very obvious, like when in case of disaster, the searching will continue on the surviving sites. So if one site is down, the another site is there, another site is up, the site which is up will serve all your requests over there, correct? And there is another important concept called search affinity, which I said, like the search head or the search heads will be basically aware about the local peers. So they will only search from the local peer. That also we can configure in the multi-site cluster. Maybe as this video is getting extended, I will talk about in the next video. So see you in the next video.